So, now the third lecture in the series of lectures for doing physics. And in the second lecture, I talked to you about the tools of doing physics. And we started with a simple tool wherein I took an isolated system in which there are only two variables, and I took it y is proportional to x. If so, we found that here x is a variable, y is a variable, and then the ensuing equation is y is equal to kx, where k is equal to y upon x. Like that, I said different values, and this is the corresponding value yn upon xn, etc. So, what happens if y is increased? X will increase. If x is increased, y will increase. But this will remain a constant. K will remain a constant. And I said that k is the constant of the system, the constant of the defined system. So, I gave you an idea that if I plot x here and y here, and then I can have also the positive values of x and negative values of x, positive values of y and negative values of y, like we have in the coordinate geometry. And here I said that let there be a value of x and a corresponding value of x plus delta x. So summing up, say that this is delta y and this is delta x, and we found that delta x definitely means that the change is small. This change could be positive, this change could be negative, and so correspondingly we have the value of this thing. Here I find that k is equal to delta y upon delta x, which I told you, if you remember, that this can culminate in ddx of y, that is rate of change of the variable y with respect to the variable x. So this is how it went, and I gave you some very example, for example, some very simple systems like the system of buying a pen or system of buying a duster, etc., etc. This is of course simple mathematical exercise. And now to elaborate it and to explain to you, of course the limit or the condition is that delta x tends to 0. I also told you that I will talk to you, because this system is a linear system, it is a straight line, but there may be things where I can say that y is a function of x, but is not a linear system of x. It could be a nonlinear system of x. I'll come to that. But first of all, a very simple example I draw from the concept of, I'll give to you the concept of what is an angle. And there I draw a line. This is the line, and it originates from here and ends up over here. If I rotate this line counterclockwise, then I call this point as O, this point as A, and this point becomes A prime, a new location. And it has been obtained by rotating this in the counterclockwise direction. Counterclockwise direction, like this. And what it results in is an arc which is the part of a circle, because if it goes around like this, we'll get a circle. So this is, I'll just write A R C arc. Now we know that this line OA or OA dash is, as we know, and in English we call it radius. The radius is not, is the same in a circle, but if I have a smaller radius, the arc will become smaller. So now the radius has been reduced and is still smaller, then the arc may become smaller in size. So all we can say that as the radius is increased, so is arc. Now this is a case of what we call proportionality or direct proportionality. Of course, we have to see that this and this and this, all these arcs, they result when there is a counterclockwise rotation, or what we call anti-clockwise or counterclockwise. Now this kind of a rotation on a plane, is called a positive rotation. The anti-clockwise, which is clockwise, if the rotation is like this, then it is called a negative rotation. So I can write that this arc, the length of the arc, which can be cut and measured, this arc is, in the system of these circles, is proportional to the radius r. And then it is equal to a constant times r. And this constant, let us call it the angle theta. Of course, a time might come when your grandchildren may not understand what is clockwise and what is anti-clockwise, because clocks are vanishing fast. Anyway, but that will be remembered for the definition of theta. So you can see that I have this angle theta which is positive. If the rotation were clockwise, the resulting angle will be negative. So arc is equal to theta times r, or I can write that theta is equal to arc upon radius. Now this theta is a constant for a given arc, which is a variable, and radius, which is also a variable. So there are two variables in the system. I can say that this is y, this is x, and this is the constant of proportionality of the system. The constant of proportionality of the system. We can have different values, but in this, for the same value of theta, we can have different values of arc, we can have different values of radius, which are related to each other by theta is equal to arc upon radius. So, now, one thing, arc is a length and radius is also a length. So, length divided by length, that will become dimensionless. So, even if we express theta, as most of you know, in radians, which is dimensionless, as also sometimes that is converted into with the system of angles that are there. So theta is equal to arc upon radius, and if we go for a circle, which has the center, which has a radius r, and which has a diameter, if I extend it to the other side, then I have a diameter d, which is equal to 2 times r. Then I can say that this is the circumference, and we can measure the circumference in terms of the unit of length, as also the diameter in terms of the unit of length. Then the diameter and the circumference are related by very simple proportionality. That is, this circumference, I'll just like CIR, circumference is proportional to diameter, which we call, in Hindi we call it vyas, and the radius we call ardhvyas. So the circumference is proportional to diameter, and then this circumference becomes equal to a constant times, I can write C is a constant times d, the diameter. And here I use the Greek term pi. So pi is, again I can say that pi is independent of C and is independent of the diameter. Here D and C, they are the variables. But pi is a constant, the constant, I'll write it CONST, constant of the defined system of system, the defined system, as I said last time, and this system is what? This is the system of the circuit. So pi, what is pi? Well, sometimes we say that we give a measure of the pi to the students, even at the primary level. Pi is equal to 3.14, okay, approximately. I'll write it approximately. This I was brought up with the value 22/7, or a closer value that was given was like this. This is equal to 355 divided by 113. So pi is a number. Pi has no unit. Pi is a number. It doesn't have any unit. So pi approximately 3.14. Okay, it has got no unit. So sometimes we test the student in lower classes that, for example, pi is equal to 3.14 centimeters, and they will just take yes 3.14, that clicks to them, but you have to care. Now this k may be dimensionless. K may be in the special case when x and y have the same dimensions, and k may have some dimension. Some dimensions. I'll let you know. There are many other things where there is so-called direct proportionality between the things, and the value of k may have a dimension, may not have a dimension, etc. Okay. For example, in the case that I said, I have money, I want to buy a pen, and this pen I have to pay 20 rupees for a pen. I said, so 40 for 2 pens, 100 for etc. 5 pens. So this is on the y-axis, I have got the money, and on the x-axis I have got the number of pens that I want to buy, in a very simple system. Therefore, the constant in that case, which is the rate of change of y, so k can have some dimension and k can be dimensionless. As I said, that if this is on the y-axis, the money that I have and the number of pens I want to buy, on the x-axis, then I obtain the constant as delta y upon delta x, which will be the money per pen, and that's nothing but the rate of a pen. Rate of a pen. So this is about the so-called the linear system, just giving you an idea, a glimpse of what is there. Now next I will talk to you about the function, the same kind of a function. Y is a function of x but non-linear. Linear, like y is equal to kx square. Y is equal to a constant x square, or y is equal to a constant x to the power of minus 2, etc. So please look into it, and I will rather with the help of this system, I will teach you together at one go what is the Coulomb's law, as also what is the law of universal gravitation, whether things go the same way. Okay, so long, see you in the next lecture. Bye.